This is the last IR video I have. So this one's going to be pretty long because what we're going to do is, so we were given 5 structures, and then I'm going to go through and try to determine which structure matches which IR and show you my thought process. It's very similar to something we gave you guys in recitation. So this is what I would do, is I know what the structures are. I was shown the structures. I see they all have aromatics, or arenes, so I can't really look at that. But I see that 2 of them have carbonyls. So the first thing I'm going to do is go see where the carbonyls are, or which spectra have carbonyls. Well, I would expect a carbonyl to be somewhere around 1700. Well, this one has 1700. All right, let's keep looking. Let's see. So we have nothing at 1700 here. So I would expect for this one, I can get rid of the aldehyde and I can get rid of the carboxylic acid. All right, let's look at this one. I also don't have anything at 1700, so I don't think this would be the aldehyde or the carboxylic acid. In fact, if I see this beautiful thing right here, I'm going to say this one is actually the alcohol. All right, and I'm going to keep going. All right, so here I don't really see something. I'm going to go ahead and eliminate and I've already found the alcohol, so I can get rid of that as well. Here in that last one, I have something at 1700. So now, again, I already know what the alcohol is. I have eliminated 2 spectra for those 2 structures. So I think it was the very first one. Let's go back. Here it is. So I've eliminated down to these 2. Now I'm just going to look and see which one's the aldehyde, which one's the carboxylic acid. That should be pretty obvious to see if I look at my hydrogen region. So if I compare, I have my first one that looks like this versus I have one that looks like this. Okay, one of those is significantly more intense. Now this looks a little narrow for a carboxylic acid, but compared to the other, that's not narrow. That's actually pretty broad. I would say that this is the structure for the carboxylic acid, even though it doesn't look quite like I normally expect it to. There could be a couple factors for that, but it's pretty clear to me that this one is definitely not going to have the intensity I would expect for a carboxylic acid. So I would expect this to be the aldehyde. I can also double check that because around 2700 is usually where I see an aldehyde peak for that hydrogen at the end right here of the carbonyl, and I do see that peak there. So it might be that my hydrogen bonding stretch isn't quite what I'm used to seeing here, but I could use that aldehyde peak to give me more confidence in my structure. So all I've done so far is look at carbonyl and then look at hydrogen bonding, and I've already gotten 3 of the 5 structures labeled. So I have the carboxylic acid, I have the alcohol here labeled with the OH group, and then I already have the aldehyde. So that leaves only the amine here as well as my pyridine. So they both have aromatics. That's not going to help me. The only thing I can do is look at the nitrogen of the M-tolididine, because I would expect to see hydrogen bonding with those hydrogen-nitrogen stretches, versus this one I would not expect that. So I'm going to look at the hydrogen region for this, all right, and that's going to be 2500 and over, and I should expect to see an amine peak somewhere around between maybe 32, 36. That's a little broad, but let's see what we can find. So I'm not seeing too much here. But if we go to this one here, all right, I'm starting to see something there. All right, so with this one, I would expect to see 2 peaks. This looks like it's 2 nitrogen-hydrogen peaks. I would guess that this is the one that has the primary amine, because I can see those 2 hydrogens. And I'm going to say that the other one, this is going to be the methylpyridine, just because I do expect hydrogen bonding to be a more intense signal. Now, that's pretty strong for amine, but it's the best option, I would say, matches up with what I expect for the compounds. All right, so this is experimental data, and again, I know you guys don't like this answer, but experimental results are not always picture perfect. But hopefully with these videos, you've kind of seen the approach that I take when looking at IR. And even if it's not exactly where I theoretically expect it to be, I can still make assumptions and I can still limit my options and determine what structure matches the spectrum. All right, so hopefully that helps with some of the IR questions you guys have had.